Welcome to Learn with Ease. I am Obina, and in today's tutorial, we are going to dive deep into conducting a one-way ANOVA analysis of variance, also known as ANOVA, using SPSS. Whether you are a student, researcher, or just curious about statistical analysis, this tutorial will help you understand and perform one-way ANOVA. Let's get started. First, let's clarify what one-way ANOVA is. One-way ANOVA is a statistical test used to compare the means of three or more groups to determine if they are significantly different from each other. This test is valuable for various research and data analysis scenarios, so depending on what you want. So before we dive into SPSS, even though my own screen is on already, ensure you have your data ready in a suitable format, just like mine. We'll discuss the data requirements and how to set up your data set for one-way ANOVA. Setting up your data set in general, I have made a video about that earlier on, so you can scroll to my earlier videos and you'll see where I discuss how you can input a data set into SPSS. Alright, so before we go on, there are some assumptions that has to be met before you would know if your data set is a data set that you are supposed to carry out the ANOVA test on. So these assumptions, I will be naming them out for you. The assumptions, they are the same with that of the independent sample test, which I've done in my previous video, but I will still say it out here for you. So the first assumption, there are 6 assumptions actually. So the first assumption is that you must have one dependent variable. In this case, we have time. You must have one dependent variable that is measured at the continuous level. That is measured at the continuous level. As you can see, our time is measured at the continuous level. Then the next assumption is that you must have one independent variable. You must have one independent variable. So this variable, that is a dichotomous variable that consists of two or more categorical variables. In this case, in ANOVA, we are using 3, so it still fits into the assumption. So the third assumption is that you should have independence of observation. That is, there is no relationship in between observations in each group of the independent variable. For instance, let's say use for instance a male and female. One cannot be a male and be a female at the same time. So that's what this assumption is talking about. You can't have one person in one variable and the same person in another variable. So that's what the independence of observation is talking about. So the fourth assumption is that there should be no significant outliers in the two groups of your independent variables in terms of the dependent variable. I've given a tutorial about outliers in my previous videos, where we talk about outliers. Outliers can either be too big, too small, or too big than other data sets that we have. So to get more on the outliers, you can check on my previous video. Then the fifth assumption is that your dependent variable should be approximately normally distributed for each group of the independent variable. I've also made a tutorial about normality tests in my previous videos. You can still scroll back and learn more about normality tests. That is, if you don't have any idea of what it is, normality tests. Alright, so the last assumption is that there should be homogeneity of variances. There should be homogeneity of variance. So if you fail any of these assumptions, it means you can't make use of the ANOVA test for your data set. And before I go on, please, very important to us, subscribe and share. I know you will enjoy this video and you get what you want from this video, so please subscribe. Alright, so let's continue. Alright, another important thing to note is that if the p-value is less than 0.05, the ANOVA test is statistically significant. If it's less than, it's not. If it's less than 0.05, it's not statistically significant. So that's one other important thing to note while carrying out the ANOVA test. So also, your data set could be imported or it could be inserted directly into SPSS. I have made videos for both of them, how to import a file from Excel, basically from Excel into SPSS, and how to impute your data set. So you can find all that in my previous videos. Alright, so to conduct one-way ANOVA, we need to define our dependent and independent variables in SPSS. Alright, so I've shown you in our previous videos on how you can know your dependent and your independent variables. But for this example, we are using cost and time. Time is the dependent variable, while the cost is the independent variable. So this data set is gotten from a company. So it's gotten from a company, a hypothetical company, where a manager wants to raise the productivity at his company by increasing the speed at which his employees can use a particular spreadsheet program. So as he does not have the skills in-house, he employs an external agency which provides training in the spreadsheet program. So now they offer 3 courses: a beginner, intermediate, and the advanced course. So he is unsure which course is needed for the type of work they do at his company. So he sends 10 employees on the beginner course, 10 on the intermediate course, and another 10 on the advanced course. But from this our example, we're using 5 on each of the courses: 5 in the beginner's course, 5 in the intermediate course, and 5 in the advanced course. So when they all return from the training, it gives them a problem to solve. Yes, using the spreadsheet program, and times how long they use to complete the task. Yes, so then he compares the 3 of them, the beginners, the intermediate, and advanced, based on the time that they use in completing the problem. So that's why we have this data set. That's why we have the course, beginner, intermediate, advanced, and the time which each of them used in completing the problem that he gave them. Alright, enough of all the long story. We have our data set here. You can find this data set already at the comments, at the description of this video. You can find the data set there and the exercise. Alright, so let's move forward. Now comes the exciting part: running the one-way ANOVA test in SPSS. We will navigate through the menus, set menus, and set our programs. So alright, enough of all the long talks. So now we have our data set ready. So we click on analyze, then compare means, then go to one-way ANOVA. Alright, so click on one-way ANOVA. Alright, so we have our cost and our time. So we have the dependent list box and the factor box. So the dependent list box is where we put our time, because our time is a dependent variable, because the time depends on the individuals in the different courses: beginner, the intermediate, and advanced. So it depends on how long they use in solving the problem. Yes, that we got the time. So that's why the time is the dependent variable. So we'll move it into the dependent list box. Then we'll move the independent variable into the factor box, which is the cost. We'll move it there. So the contrast should be like that. Don't need to add anything there. So the post hoc helps us to know the difference in between the groups. In general, ANOVA helps us to know if there's a difference in mean between the dependent and the independent variable. But the post hoc test helps us to know if there is, to know the differences, to see the differences in between the groups, in between beginner, intermediate, and advanced, like that. So that's what the post hoc test does. So in this post hoc, we use the Turkey post hoc test for multiple comparisons. And so we select the Turkey, then we leave it at a significance level of 0.05, then click continue. Then the options, we should leave it that way. It should be like that. Okay, let's see the homogeneity of variance test. Yes, let's include it there because it's part of the assumptions of ANOVA. Right, so click on continue, then that is all. We leave others as they are, then we'll click on OK and wait for our output or result. Alright, so we have our output ready. Alright, so now understanding how to interpret the output in SPSS is very crucial. You might run the test, that's easy, but if you don't know how to interpret the output, is all lost. Alright, so we'll cover what the output tables means, including the ANOVA table, the Levin's test, the homogeneity of variance, and the post hoc test, that is the Turkey post hoc test. Alright, so let's start with the test of homogeneity of variances. So in there we have the Levin's test, Levin's statistic. Alright, so the Levy statistic says that if the significant value is greater than 0.05, then it means there is a mean difference in the statistically significant difference in the mean. So here we have all through we have values that are greater than we have values that are greater than 0.05. So there's a statistical significant difference. Alright, so from the ANOVA table, the ANOVA also the conditions that we have there is that if the significant value or the p-value is less than 0.05, then there is a statistically significant difference in the mean. Alright, so here we have 0.008. So this means that the ANOVA is statistically significant. So the difference in the mean is statistically significant. Alright, so now we move down to the post hoc test. So this post hoc test, like the table heading here says, is a multiple comparison. It compares groups between groups, the differences between group. Now we know that the ANOVA is statistically significant. So their differences are statistically significant. That means there's a difference between beginner, intermediate, and advanced. So the manager can choose which is more effective, which the differences. So you cannot choose from one. So now ANOVA has let us know that there's a statistically significant difference in the means. So now the Turkey post hoc test is trying to show us where those differences comes in, where there's differences, which of them are different from which, and which of them are still same. So here, right here, we have the beginner and the intermediate and advanced. So we'll try to compare the beginner and then how the beginner has difference between the intermediate and the advanced. Alright, so we look at this, then we look at the significant value. So the difference between beginner and intermediate, the significant value here we have 0.821. This means that there is no significant difference. Then between beginners and advanced, we have 0.009. This means there's a statistically significant difference between the beginner and the advanced. So assuming we have just this to pick, we'll see that the beginner and the intermediate has no statistically significant difference. So we can choose the advanced. Alright, but we have more still to go. So now the difference between the intermediate, if there's any difference between the intermediate and the beginner, any difference between the intermediate and advanced, we look at the significant value also. So here we have 0.821. So just the same thing that we had here. There's no difference, statistically significant difference between the intermediate and the beginner. But we have a statistically significant difference between the intermediate and advanced, which is 0.025. Remember, if it is less than 0.05, there is a statistically significant difference. So now we come down to advanced. Here in advanced, we have advanced and beginner 0.009. That means there's a statistically significant difference. Then between advanced and intermediate, we also have a difference because you have 0.027. So there's a statistically significant difference. So this is basically what the Turkey post hoc tells us. It tries to show us in detail the differences that these groups have with each other. So now the homogeneous test is to know if there's homogeneity. It should be greater than 0.05. So right here we have a significant value to be greater than 0.05. So this means that there's homogeneity. Alright, so that's how we interpret outputs. So we'll move to how we can interpret our report our results. So I will guide you on how to report the results of your one-way ANOVA analysis in a clear and concise manner, which is essential for academic and research purpose. Alright, so to report the output of the one-way ANOVA, you can report it based on how you've understood it and in a way that it will be clear to your audience or to whomever is reading your report, even if it's for research purposes or educational purposes. Alright, so but basically this is a clear way that you can interpret results. So you can interpret your results this way, that there was a statistically significant difference between groups as determined by one-way ANOVA. Here we have the frequency of 2 to 12 and we have the p-value which is equals to 0.0059. Sorry, 0.009. I have all that in bracket. Then now you've said that, having said that, you now give the report for the Turkey post hoc test. You say a Turkey post hoc test revealed that the time to complete the problem was statistically significantly lower after taking the beginner's course. That's the reporting what we got from the post hoc test, the Turkey post hoc test here. Let me repeat that. A Turkey post hoc test revealed that the time to complete the problem was statistically significantly lower after taking the beginner's course, where we have the mean there. Then we have the p-value of 0.009, and intermediate we have 1.6 plus or minus 0.9 with a p-value of 0.27. Because compared to the advanced course, there was no statistically significant difference between the beginner and the intermediate groups. So there was no statistically significant difference between the beginner and the intermediate groups. So from this report, what do you think the manager will do? From this report, the manager will have to pick the beginners and the intermediate groups, because the beginner and the intermediate groups finish their own task on time. They finish the time it took for them to finish their time were lower compared to the advanced. So the manager would rather pick the beginner or the intermediate group, because their differences, when there were no differences at all. So it could either pick the intermediate or the beginner. So this is basically what the post hoc test does. It gives us the difference in details. So that's it. You've run an ANOVA test. Congratulations, you've completed our comprehensive tutorial on one-way ANOVA in SPSS. This statistical technique can help you gain valuable insights from your data, just like we've seen from this exercise or example that we've done. So if you found this tutorial helpful, please like and subscribe to Learn with Ease for more statistical analysis, tutorials, and data-driven insights. Thanks for watching, and I'll see you in the next video. Yes. So if you have any questions or suggestions for future tutorials, please don't be shy to leave a comment below. Keep analyzing, keep learning, and until next time, happy data crunching.